Current electricity problems for JEE Main and Advanced. Why I am discussing this topic in this video? Because 2 to 3 problems in every JEE Main papers it is coming, and you can expect one good problem in advanced paper as well. So if you have clear concept on this topic, you will get 12 marks in JEE Main paper on an average. Okay? Now it is very easy to solve. I am saying it will be easy if you have a clear concept on this topic, and this video will give you clear concept to solve all the problems. And why I am discussing? Because I am an expert in circuit theory. I am teaching the circuit theory course for B.Tech for several years. Not only this, I am teaching analog electronics, electromagnetic wave theory, many things in advanced topic B.Tech bachelor levels. I have one more channel, that is RLD Academy, that is for GATE exam. It is actually for B.Tech student. Okay, if you want, you can explore this channel. You can find some interesting videos there, even in circuit theory. Now, are you feeling comfortable to solve these electricity problems? If not, you can follow this video. Just spend 1 hour with me. You will get everything. Okay, first I will discuss the basic theory, and then I will solve few interesting problems which are generally coming in JEE papers like this. So it is very easy to find equivalent resistance from here. I will show you later. Even this problem, we can easily find out equivalent resistance for this complicated circuit. This one, it's also easy to solve this one. This one, this kind of problem, if there is a branching, that also you can tackle. What will be the current through this 20 ohm resistance if the voltage and this voltage are given? That is very easy. Okay, just follow me. Even you will be able to solve this kind of difficult problems at the end of this video. So don't skip any part. Try to follow my video. Take your pen and paper. Just note down whatever I am teaching to you. So are you ready? Okay, we'll start now. First, we'll try to understand what is current. Okay. So this current is nothing but, this current generally it is denoted by capital I. This I will say that it is the change of charge or flow of charge, dq dt. But this q is a movable charge. Generally it is electron. Okay, so electron is negative charge carrier. That charge carrier can flow through a conductor. So if you have one conductor, this kind of conductor, then through which the electron can flow. Okay, so to get the electron, what we will do, we will connect one potential source or battery with this conductor. Okay, this battery source will have two polarity, two plates. This is a positive plate, this is a negative plate. A negative plate is the source of these electrons. So here it can generate electrons, and those electrons can move through this conductor. Okay, and then ultimately it will be collected to this positive plate. So this is the motion of electron. This is the direction or motion of electron E. Remember, electron is negative charge carrier. Okay, so whenever this electron is moving from negative terminal through this conductor to positive terminal, we will consider that current is flowing from plus terminal to minus terminal in outside circuit. So this is the convention of current direction, capital I, because the current is made of this electron, and electron is basically negative charge carrier. Thus the direction of current is taken as negative of the flow of charge of this electron. Okay, because electron is negative charge carrier, it is flowing from right to left, so we will consider current is flowing from left to right. Okay, it's opposite of flow of electron. So this is the notion, the direction of current. Okay, so if this potential is V, then we can have certain current. Now we can understand that this conductor, this is your conductor through which current can flow. Now it depends on the good conductor or bad conductor. If it is a good conductor, then we can expect more number of current. Okay, so it's a good conductor that from here, so if V is made constant, the current could be large. Okay, and for bad conductor, this bad conductor, the current cannot flow easily, so I is low. That is a simple thing we'll assume, right? Now how good or bad it is, it depends on the material or the size, everything. Okay, so any conductor, if it is a bad one, it will try to oppose the flow of the current, and from there we'll get one concept of resistance. Okay, so resistance is denoted by capital R. So it will resist the flow of current, right? Okay, so this resistance R depends on this material rho, the length of this conductor, and the cross section of this conductor A. So R will be equals to rho times L upon A. This is the resistance of any conductor. So in this video we will not focus on how to calculate the resistance value. So the unit of resistance is ohm, that also you should remember. But here we will consider how to use the resistance in the circuit. So this thing will take care later. R equals to rho times L by A. Rho is called resistivity, L is the length, and A is the cross sectional area. Okay, now we will go for this Ohm's law. So this is the most important law. So we will indicate this kind of symbol to represent resistance. So its resistance is R, suppose. Now its Ohm's law says that if we have a potential gap between these two terms or elements, okay, this potential is VA, this is a node A, this is another point or node B, and here potential is VV. So this gap, okay, this difference VA minus VV, if this is suppose V, and if I apply this kind of potential across the resistance, we will get one current I, and that current I is directly proportional to V. Okay, proportional to V. Or I can write that if the current is flowing I through the resistance, then potential will develop across the resistance, and that potential V is also proportional to capital I. So any one we can use these things. Remember that temperature is made constant. So T is constant. That we will assume, because if we vary the temperature, resistance value will vary. Okay, so we will keep the temperature constant. In that case, V is proportional to I. So here we can write that V equals to I times R, where R is the resistance. So this is the important formula to relate this voltage and current in resistance. Okay, this is very simple. Now you can understand that what is I will be V upon R. So if R is increasing, so that imply if R is increasing, obviously I will get less current. Okay, so if resistance value is more, the current will be less because it will oppose more. You will get less current for same amount of potential V. Okay, so meaning is that suppose if I have a battery source like this, and then if I connect here one resistance R, suppose this resistance value is 2 ohm, and if I apply 10 volt source, then current through this resistance I, this resistance R would be I. This I is simply this voltage upon the resistance. So this voltage is V, this is R. So in this case it is 10 volt and this is 2 ohm. So 10 by 2 equals to 5 and unit is ampere. So unit of voltage is volt, unit of resistance is ohm, okay, and current its unit is ampere. Okay, so you can see that if I increase the resistance value, suppose same potential was there. Now if I consider one resistance and that value is R equals to suppose 10 ohm and same potential 10 volt. So in this case this current I for this one, it is simply 10 volt upon 10 ohm means only 1 ampere. So you can see that if resistance value is more, you will get less current. That's very simple. Now if the circuit is having more than one resistance, then how to tackle these things? So, okay, that thing we will discuss. So two things we will discuss. One is series connection of resistances, other one is parallel connection. Okay, so from these 2 points topics problems are coming. Okay, so in series connections the resistance are connected one after another. Okay, the end of one resistance, other resistance is connected. Okay, so these resistances are R1, this is your R2, this resistance is R3. They are connected one after another. Then if I add one source, a battery source, this is capital V. So in this circuit we will get a current flow. This current flow is I. Now you can see that as the resistance are connected, so in series you will get the same current. I will be same through all the resistances. Okay, resistors. That is the most important part. So in series connection, resistances are connected one after another and current through the resistances should be same. Okay, because there is no branching, nothing that. So current through R1 is I, R2 is again I, R3 is also I. Okay, now if it is so, then what is the voltage drop across this R1? What is the voltage drop across this R2? And what is the voltage drop across this R3? Okay, so if I take few points, this is a point A, this is a point B, this is a point C, this is a point D. Okay, so I can say that the VA minus VB, this gap, according to Ohm's law, it will be I into R. Here it is I into R1. Is it right? Similarly, the potential gap between B and C, I can write VB minus VC. This is your I into R2, because same current is flowing, this current is I, so potential gap between these 2 points B and C will be I into R2. Similarly, VC minus VD, this potential gap, again the same current I, so it will be I times R3. So if I add all those three, okay, if I add, simply add, what will happen? So VB will cancel out, BC will cancel out, so this will give you VA minus VD. So VA minus VD, this one will be, I can add this one, IR1, IR2 plus IR3. So I can take common, this is simply R1 plus R2 plus R3. So that I can write one resistance only, I into R equivalent resistance. Okay, so this equivalent resistance now it is becoming, what is R equivalent? It's simply addition of those resistance R1 plus R2 plus R3. So I can consider that same circuit, this is equivalent to only one resistance R equivalent, okay, with the same voltage source V, I will get the same current I. Okay, where R equivalent will be addition of, simple addition of all the resistance R1 plus R2 plus R3. If I have more resistance, I can just add all those things. So in series connections, the resistance are added up to get the equivalent resistance. Now in parallel connection, it is just opposite. What is that? So the resistance are connected parallelly, meaning is that the end to end points are same. So all the elements or resistances are connected between these 2 points A and B. And now here, if I add one source between these 2 points A and B, so this supply voltage is V. So it will supply capital V voltage between A and B. And every resistance, this R1, R2, R3, they will get the same potential because end to end point is same. So in parallel connection, the potential gap VA minus VB will be the same for all the resistances. Okay. Now their current could be different. So this current is suppose I1, this current is I2, and this current is suppose I3. Right. So what is your I1? So now I can use Ohm's law because potential across this R1 is again VA V minus VB, that is equals to V that I have considered. Okay, so I can write this V equals to this V equals to I1 times R1. So from here I can find out I1 equals to V upon R1. Similarly, V equals to, again I can write I2 into R2 because same potential between, it is also connected between A and B and potential gap is V. Okay, so in parallel connection, remember the potential gap is same, then only it is parallel connection. So what is I2? The voltage upon resistance R2. Similarly, the V equals to I3 into R3. From there I will get I3, that is equals to V upon R3. So what is total current? I. So that I can write, it is the addition of this 3, I1 plus I2 plus I3, because whatever current is coming here, that is some current is going through this side, one current is going to R2 and other current is going through R3. Okay, so this current continuity is important, that is called Kirchhoff's current law, but no need to use this name. So this is your, you can use one concept, Kirchhoff's current law, that is in short it is called KCL, that will be discussed later. But here is the simple thing is that whatever current is coming here, that has to go through other branches. So this is through R1 is I1, through R2 it is I2, through R3 it is I3. So total current I equals to I1 plus I2 plus I3. So now I can replace. So this V I can take common. This is 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay. So you can see that this one, so this total current I can replace by V by R equivalent, one equivalent resistance like this. This replaces one resistance and one potential source. These are equivalent. I should get the same current I. This is same potential V. So easily you can compare this one. So what is the relation? So from here you can see that this V I can write, or this V equals to I into R equivalent, or I equals to B by R equivalent. So I can compare these and this. So what I will get? I will get this for parallel connection. What is happening? This I have got V times 1 upon R1 plus 1 upon R2 plus 1 upon R3 like that. That is also same as B upon R equivalent. Just comparing these two, I can write this 1 upon R, B will cancel out, this B will cancel out. So it's 1 upon R equivalent is 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, this is very simple thing. Okay, now you can take few examples. Suppose I have two resistances. This is your 3 ohm, this is your 2 ohm. So this one I can replace by single resistance R equivalent. What is the value? Simply addition of these two. 3 plus 2 equals to 5 ohm. Okay, now I can take one example that, so this is your two resistance, they are connected in parallelly. So it is your 4 ohm, this is also 4 ohm. So what is the R equivalent? So this R equivalent, 1 upon R equivalent will be equals to 1 upon 4 plus 1 upon 4. This is 2 times 1 upon 4. That will give you this 2. So this is R equivalent equals to 2 ohm. So here what interesting thing is that if I have only two resistance, right, this is your R1 and R2, between these 2 points A and B, R equivalent could be considered easily, that is R1 into R2 upon R1 plus R2. Multiplication of these two resistances by addition of these two resistances. So if you use these things, it is a 4 into 4 upon 4 plus 4. You will get again 2 ohm. Further, if the resistances are same, R1 equals to R2 equals to R suppose. So easily I can show that R equivalent will be, so this is your R, this is your R, and this is R plus R is 2R. R will cancel out, so you will get R by 2. It's half of that. So if it is 4 and 4, half of that is only 2 ohms. Okay, this is 4 by 2 equals to 2 ohm. So it is very easy. So similarly, if I have, so it is 10 ohm, 10 ohm. So its equivalent resistance is very simple. It will be 10 by 2, half of that, it will be equals to 5 ohm. Similarly, if we have more number of equal resistances, so I have 4 resistances and all are having 8 ohms, equal 1. So R equivalent will be, so as this 4, I need to divide by 4. So 8 by 4 equals to 2 ohm. Very easy. Okay. R equivalent will be, so number of elements you need to consider. So if there are n elements, then R equivalent will be this total R resistance by capital N. N is number of parallel resistances. Okay. It is very easy. You can remember these things. And few important parallel combinations, those are we are getting frequently. One is suppose 3 ohm and 6 ohm. What is this equivalent resistance? It is 3 into 6 multiplication of these two by addition of these two. Okay, so 3 into 6 by 9. So 3 and 3, 2 is the 6, so it is 2 ohm. Okay, so combination of 3 parallel 6 will give you 2 ohm. So that you need to understand quickly. Okay, so similarly this 30 ohm, 60 ohm, you will get 20 ohms. It's very easy. Okay, we will solve few problems on this topic. Okay, and from this only we can solve lots of problems from JEE main paper. Okay, let me discuss this one. This is the first problem. Okay, can you find equivalent resistance of this network? And this problem appeared in 2021. Okay, so how to proceed? So you have to look from this AB terminal, from this side. Suppose current is coming. Okay, I'll take different color. So this current is coming I. So when same current is flowing, I have said that it is a series resistance. When current is sharing, is dividing, then there is a chance that the resistances will be in parallel combination. But if they will start from one point and then again they will meet another point, then only they are actually parallelly connected. So here you can see that these 3 ohms and this one, these two nodes are same, because in between there is no resistances. It is same node and it is also same node. I can say that this 3 ohm, this 3 ohm is exactly parallelly connected. But this 2 ohm, I can't say that 2 ohm will be connected to parallelly with 3 ohms. No, because this 2 ohm is, this end point is different from this one. Okay, be careful. Thus, we can't say 2 ohm is parallelly connected to 3 ohms. Again, 2 ohm is also not connected in series with 3 ohms. Right? Now, again we have to go further. Now there is again another branching here. There is a possibility that this 2 ohm will be parallelly connected, but this end and this end. Now you have to look at this one. Now this point and this point, these 2 points are actually same point. Okay, and now here there is a short circuit. So if anything is shorted, so this resistance is 0, though all the whatever current is coming here, that has to go through this side. So it has no effect at all. So we can ignore this 5 ohm resistance, because through 5 ohm resistance no current will flow. If anyone is short circuited, so current will flow through that path only. So this 5 ohm I can omit, I can remove. Now we can see, so if I redraw the circuit, this 2 ohm and this 2 ohm, this current will, some current will flow, some current will flow here, and now they are connected again in the same point. So this 2 ohm, this 2 ohm, they are really connected in parallel. Okay, so these two I can combine. So what is the value? Parallel combination of this one, this R equivalent to 1. I can say 2 parallel 2 is simply 1 ohm. Half of that, it's 1 ohm. Okay. Then I'll connect the rest part. So rest part is this 2 ohm resistance, this 2 ohm, then this 3 ohm, and then this 3 ohm. this is the node A, this is the node B. Now you can see that whatever current is flowing through this 2 ohm resistance, so it is one equivalent resistance, so I can redraw the circuit. So this is one resistance, that is 1 ohm, and now this is your 2 ohms. Okay, and between these two there is one resistance 3 ohm, another resistance is 3 ohm. This is your A, this is your B, this is 3 ohm, this is 3 ohm. Now same current is flowing through this one. So now 2 ohms and 1 ohm, they are connected in series. So this one I can replace by one resistance, this one. So its resistance is 3 ohm because they are connected in series, because same current is flowing. So what is now equivalent? So this is your 3 ohm because of this. Then another 3 ohm is here, another 3 ohm is here, and then this is the node A and B. This is your 3 ohm, this is also 3 ohm. So what is your R equivalent? Now it is simple. So these 3 resistances are connected parallelly and all are same value. So it is divided by 3. So R equivalent will be R upon 3. So in this case it is 3 upon 3 means 1 ohm. So answer is 1 ohm. So it's very simple. So be careful about this part. Okay, whenever there is short circuit, so this resistance will have no effect. We can remove that one. Now this 2 ohm parallelly connected. That resistance is equivalent is 1 ohm. That I can consider here. Then that 1 ohm and with this 2 ohm, they are connected in series. I'll go for this 3 ohm. Now this 3 ohm is connected now parallel with this 2 resistances 3 ohms. So total equivalent resistance will be 1/3 of total resistance. Each resistance R. So it is 3 by 3 equals to 1 ohm. I think it is clear. Okay. Now we'll move to the next problem. Can I find the equivalent resistance of this one? So you can, for this kind of problem, always consider the junction points. So this is your C point and this is your some points. Okay. So now you can see this is sorted path. So actually B and C, it is basically same. So no need to consider new points. So this is also B, because there is no potential gap between this and this. Similarly, this node point is A, this is also A, and this is also short path. This point is also A. I can consider same potential. So now we can redraw the circuit. This is your A, this is your B. So between this one, if I consider A and B, there is one resistance 20k. Now this one, this is also between A and B, 20k. Okay, from this to this side. So that also I can consider. Okay, this also 20k. Now this one, it is also again between A and B. So it is also between these two. So effectively all 20k is, so this is your 10k, sorry, this is your 10k. Okay, 10k is also connected here. So now how to consider? So you can see that all the 3 are connected parallelly. So I can go one by one. It will be easy for us. So these 2 I can combine first. So 20k, 20k, it is half of that. So I can consider one resistance, that is a 20 by 2 means 10k. So okay, I can consider 10k. Then this 10k, it is now parallel with this 10k. Okay, this is your A into B. So what is our equivalent? So this 10k, 10k parallel connected, it's half of that, 10 by 2 equals to 5k. Okay, so answer will be 5k ohm. Okay, not only 5 ohm, 5 kilo ohms, right? So this is the question from 2023. It's very easy. You need to understand how they are connected, whether resistance are connected series or parallel. Okay. Let us consider the next problem. This one. So this looks very complicated, but it is not really complicated. Okay. This resistance is R. Okay. I'll consider this one. This is R. This is R. Okay. All resistances are R. Remember. Okay. Now here one important thing is that, can you find out this thing? This is short path. Again, this is your short path. So this node and this node potential is same. This node and this node potential is same. Again, it is shorted. This node same. So eventually you are having a short path here. So all the current will pass through this shorted path. So there is no effect on this thing, no effect on other part. So everything is short circuited. So I will be having only these things. This resistance R and this resistance R, and this part is shorted, nothing else. So this is your A and this is your B. So what is the resistance? Equivalent resistance then. So same current is flowing to this side. Okay, so R equivalent will be the series combination of these two. So R plus R equals to 2R. It's very easy. Okay, so this appeared in 2021. Right? Now next problem. This one. Can you find the equivalent resistance between A and B? Right? So how to find out? Look at the problem very carefully. So you need to identify this node is one node. This is again the same node. This side, this is the B node. This is B node. This is B node. Okay. This is a different node. So it is C node. Right? So what I can do? I can combine the resistances. So these two resistances I can combine easily because they are connected in series. Whatever current is coming, it has to go through. So whatever current is going through 1.5 ohm, that has to go through 0.5. They are connected one after another, means series. So equivalent resistance of these two will be 1.5 plus 0.5 equals to 2 ohm. That's simple. Similarly, this one, whatever current is coming, it has to go through this one. This also 1 plus 1 equals to 2 ohm. Okay. Now I can redraw the circuit a little bit. So can I redraw the circuit? So this is the node A, this is the node B. Between these two nodes, this above one, this one, I have one resistance between A and B, that is your 2 ohm. And this resistance is also 2 ohm. Okay, that one can I write here? Easily I can write. This is also 2 ohm. So this one I have also connected. Then this 12 ohm between A and B, I'll put it here. So this is node B, okay? This is your 12 ohm. Similarly, this 6 ohm, it is also between A and B. I can consider these things here. This is your 6 ohm. Now, this 8 and 2, so that is why I have one node here. Now, between these two, A and C, I have one resistance 8 ohm. And then it is parallel connection 2 ohm. It is your C point. Similarly, this 4 ohm between C and B, okay, I can connect here, no issue at all. And this is your 4 ohm and this is your 6 ohm. Right? Now we can easily combine all the things. So how to combine? Now it is sure that these two are parallelly combined. So what is the equivalent resistance? 8 into 2 by 8 plus 2. What is the value? It is 16 by 10 means 1.6 ohm. What is this 2? This is 6 into 4 by 6 plus 4 means 24 by 10 means 2.4 ohm. Okay. Then combination of these two, because now they are connected in series. So this will give you, total will give you, this 1.6 plus 2.4 is 4 ohm. Okay. So this whole combination I have got it. What combination? This combination. This will give you the 4 ohm. Now all are connected parallelly. That also we can do one by one. Okay. So how to proceed these things? So this 12 and 6. Okay. So this one 2 and 2 will make 1 ohm. Parallelly connected. Okay. And this now 12 and 6, how it is connected? Right. So this parallel connection of these two, it will be 12 into 6 by 12 plus 6 equals to 12 into 6 by 18. So it is 3 and it is 4. So it is 4 ohm. So this will give you 4 ohm. This is your 4 ohm. This 4 ohm, this 4 ohm. Okay. It will give you parallel combination of this one. Okay. So I can redraw the circuit now. The last one. I have got this 1 ohm for this one. This 4 ohm I have got for this one. Okay. These things. And last one, this 4 ohm I have got from here. Okay. So this 4 and 4 parallelly combined. So I can go for 2 ohm, half of that, 2 ohm. So actually this 2 ohm and 1 ohm are parallelly combined. So what is the R equivalent? It's simply 1 into 2 upon 1 plus 2. So it is 2 upon 3 ohm. So answer is done. So it looks complicated, but it's not that much complicated one. Okay. Now go for next problem. Now consider this problem appeared in 2021. Now how to solve these things? One galvanometer is given. Okay. It is connected in shunted means parallelly with 5 ohm resistance and 2% current is passing through it. Okay. So if I have this resistance, this is your 5 ohm. I have one galvanometer G that is connected across this one, and it is saying that whatever current is coming here through this galvanometer, only 2% is going through. So 2% means, so 2% of I means 2 into I by 100 means 0.02 times I. Okay. So in this side you will get 0.02 times I. Correct. So rest current, obviously it has to go to this side. So this 2%, so obviously this side 98%. So this current will be 0.98 I. I think it is very simple. Okay. Now as these 2 points are connected between these two node A and B, both will have the same potential gap. If this resistance is Rg, so the voltage drop across this galvanometer will be this current into resistance. So this current is 0.02 I and resistance is Rg. This is the potential gap across this one, and that will be same as potential gap between this 5 ohm. So what is that? The current is 0.98 I and resistance is 5 ohm. Multiplication I into R, you will give you the potential gap, and these two should be same because they are connected parallelly. Okay. So this I will cancel out. So what is your Rg? Rg is very simple, 0.98 times 5 upon 0.02 So if you simplify, this 2 will be 49. So 49 into 5, it will be your 245 ohm. Okay, this is done. I hope you have got this. This is not difficult one. So resistance of this galvanometer is 245 ohms. Now next problem. Can I solve this one? So this is the node A, node B, node C. Its value is given 30, 12 and 2 volts. So this is your 30 volt, this is your 12 volt, this is your 2 volt. Okay, so this junction potential is not given. I'll call it capital V. Okay, I said that whatever current will come from one branch, it has to go through other branches. Okay, if this current is I, this current is I1, this current is I2, so obviously I can write this I equals to I1 plus I2. So what is the current I? So this potential gap, this node potential is 30, this node potential is V. So this is 30 minus V, this is the gap. And what is the resistance? Resistance is 10. So this is the current through 10 ohm resistance. Okay, that is equals to, so what is the I1? This potential is V, this is your 12 volt. So it is V minus 12 and resistance is 20, so by 20. Plus, what is I2? It is this V minus 2 by 30. So I have got one equation. I can solve it. So these two I can combine. It is a 60. So this is your 3V minus 36. This is your plus 2V minus 4. Okay. So if I combine these two, it is 5V minus 40 upon 60. So this you will cancel out 6. So if I multiply this one, this is 180 minus 6. I am multiplying with the 6 minus 6V, that will be equals to this 5V minus 40. So if I simplify this one, this 180, this I will bring 40 this side, equals to 5V plus 6V. So that will give you 11V equals to 220. So what is the V? V equals to 220 by 11 means 20 volt. So this node potential is 20 volt. Now it is done. So what is the current flow? Through this 20 ohm, that is your I1. I1 is V minus 12 by 20. So what is the value? So it is 20 minus 12 by 20. So this value is 8 upon 20. So this is 4 upon 10. That means 0.4 ampere. Okay, this is the answer. So is it difficult? I think it is not a difficult one. I hope you have got these things. Next problem. Can you solve this one? It looks little bit complicated, but can you solve it? So this circuit is drawn. All the points are given. Take carefully. This is node A, this is node C, this is node D, this is node B. Okay. So this VA, this node potential is VA, this node potential is VC, this node potential is VD, this node potential is VB. I need to find out VB minus VA. Okay. So can I consider this term first? So what is the gap? Okay. So this is the higher potential I can consider. So this VA minus VC. Okay, with this VA 1 volt is added, then we will get VC. Otherwise I can write VC is higher, VC minus VA, this minus this is equals to 1 volt. Because VC is more than VA by 1 volt. That is the meaning, because 1 volt is given. So with VA 1 volt is added, I will get VC. Okay. Now here what is the important thing? VD minus VC. How to get that one? So what is given here? This current is 1 ampere. Means this current is coming 1 ampere. This current is 2 ampere. So obviously if I apply this node here, so some 1 ampere current has to come from this side. This 1 ampere, this 1 ampere will give you this total 2 ampere. That is very simple. This is applying KCL, Kirchhoff's current law. That will be discussed in detail later. But here it is very simple. This branch current is 1 ampere. This downward current should be 1 ampere. Then only it will add up to 2 ampere. So if it is 1 ampere, what is the potential gap between these two? I into R. So this VD minus VC will be I into R. Means in this case 1 ampere into 2 ohm. So it is a 2 volt. Okay. Now this VD and VB. So VB minus VD. Okay. With this VB minus VD. Now you see this VD is more. With this VB 2 volt is added, we will get VD. Okay. So VB minus VD will be the opposite, negative 1 minus 2 volt. Okay, because VD is more compared to VB by 2 volt. So VD minus VB is 2 volt, but it is VB minus VD is negative of that, minus 2 volt. So if I add all those things, what you will get? Simply this VD will cancel out, this VC will cancel out. So VB minus VA, this VB, this VA, it will be simply this addition of these three, 1 plus 2 minus 2, this 2 will cancel out, it is a 1 volt. So VB minus VA is simply 1 volt. Have you got these things? Okay. If you have liked this video, please press the like button, and I will be discussing more problem in this channel. And if you go through all the videos, then I hope you will be able to solve any problem from circuit electricity, current electricity. Okay. So keep watching. Thank you very much.